Every sci-fi empire you've ever imagined is a beautiful lie. Humanity is currently serving a life sentence in a cosmic quarantine, trapped behind an impenetrable wall. But this barrier isn't made of superheated plasma or hyper-advanced alien technology. It is made of absolute, terrifying nothingness. We look at the stars and assume our arrival is inevitable, a mere matter of time and engineering. But physics does not care about human ambition. Carbon-based life forms like us are tethered to the specific sun by laws of nature that refuse to bend. Even if millions of hyper-intelligent civilizations exist in the Milky Way right now, they are likely suffering the exact same fate, dying entirely within the stellar cribs that birthed them. To understand why we are imprisoned, you first have to unlearn everything your ape brain believes about distance. Our brains evolved to calculate the distance between a predator and a hiding spot, not the gulf between celestial bodies. To comprehend this prison, let's weaponize human scale. The fastest object humans have ever forged relies on a heliophysics cheat code. The Parker Solar Probe slingshots around Venus, falling toward the sun at a staggering 635,000 kilometers per hour. A commercial airliner would need nearly a month to cover the distance this probe travels in 60 minutes. At this velocity, you could circle the Earth in 4 minutes. If we loaded a crew into a vessel moving this fast, the cosmos suddenly feels conquerable. We would blast past the moon in 36 hours and arrive at Mars in just 2 weeks. But the illusion of victory is fleeting.
Leaving Mars behind, we plunge into the outer dark. Reaching Pluto requires an entire year in absolute isolation. We cross the heliopause, blowing past the Voyager probes, which took half a century to get here. In just 36 months, we are flying faster than humanly conceivable. But to actually leave the solar system, we must traverse the Oort cloud, a spherical graveyard of icy debris. At our record-breaking speed, reaching the edge takes 2,500 years. If you launched this ship during the dawn of the Roman Empire, the crew would just be arriving today. And what awaits them? A suffocating, endless void. The scale crushes our optimism. But distance is merely the opening act of this tragedy. The true horror isn't how long the journey takes. It's the fatal consequence of trying to cheat time. Since time is our enemy, the obvious solution is to manipulate velocity. We must bend the limits of propulsion. Forget chemical rockets. They are glorified fireworks. We need controlled nuclear fusion or antimatter engines, harnessing the primordial fires of creation to push a vessel to 20% the speed of light. Let's assume, wildly, that we solve the unimaginable thermodynamic nightmares of containing an antimatter reaction. Suddenly, our vessel is slicing through the vacuum at 60,000 kilometers per second, 216 million kilometers per hour. At this godlike velocity, that grueling 2.5 millennium crawl through the Oort cloud is violently compressed. We reach the absolute edge of our solar system in just 8 years. The nearest star system, Alpha Centauri, is suddenly only 2 decades away. We've unlocked the galaxy, or so we think.
But physics demands a bloody toll for approaching the cosmic speed limit. At 20% the speed of light, the definition of a vacuum changes. Space is not truly empty. It is a microscopic minefield of stray hydrogen atoms, interstellar gas, and wandering molecules. When you accelerate to a fraction of light speed, you weaponize this invisible dust against yourself. In the realm of extreme relativity, kinetic energy scales exponentially. A single, solitary iron atom striking your hull at this velocity ceases to be gas. It becomes a hyperkinetic projectile, carving a microscopic canyon into aerospace-grade titanium. Within hours, the pristine armor of your multi-billion-dollar starship will be sandblasted into a brittle, perforated sponge. You are flying through a storm of invisible bullets, and the universe has infinite ammunition, but atoms are the least of your worries. What happens when you encounter something larger than an atom? A single speck of interstellar dust, something you wouldn't even notice on your living room table, strikes your vessel with concussive force of a detonating hand grenade. The impact instantly flash vaporizes, tearing a catastrophic crater into your shielding. Now, imagine a road pebble, a silent, frozen rock no larger than a standard golf ball, drifting aimlessly in the dark. If your ship collides with this pebble at 20% the speed of light, the kinetic energy released is unimaginably violent. It detonates with more than twice the explosive yield of the nuclear bomb dropped on Hiroshima. There is no alarm, no evasive maneuver. In a microsecond, your triumphant interstellar vessel is reduced to a cloud of expanding radioactive plasma, joining the very dust that destroyed it.
To survive this kinetic hellscape, engineers must mount an armored shield of unprecedented proportions to the front of the vessel, perhaps a massive block of ice or solid tungsten meters thick. But here we encounter the cruelest paradox of orbital mechanics, the tyranny of the rocket equation. Mass is the enemy of speed. The thicker your shield, the heavier your ship. The heavier your ship, the more antimatter you need to accelerate. More antimatter requires heavier containment systems, which requires more fuel. You are trapped in an inescapable mathematical death spiral. Pushing a heavily armored dreadnought to relativistic speeds requires energy outputs rivaling the total consumption of planet Earth. Even if humanity unifies to harvest this monumental power, shielding only delays the inevitable. We are forcing fragile biology into a physics equation meant for gods. But let's play the ultimate game of optimism. Miraculously, our shielded crew survives a 20-year sentence locked inside a claustrophobic metal cylinder. They endure cosmic radiation, psychological torment, and zero-gravity muscular decay. They finally break into the Alpha Centauri system, tears of triumph in their eyes. They boot up their sensors to survey their new kingdom, and they discover a barren wasteland. Alpha Centauri is utterly sterile. The planets are either irradiated husks or toxic gas balls. They sacrifice their entire existence, traveling through a gauntlet of nuclear-yield pebbles just to look at different rocks. The cosmic joke is that the universe doesn't care about our effort. Achieving the impossible doesn't guarantee a paradise. The nearest destinations aren't just unimaginably far. They are scientifically, violently hostile to carbon-based apes looking for a new home.
To find a true oasis, we must zoom out again. Imagine our stellar neighborhood as a bubble 25 light-years across, a microscopic fraction of the Milky Way. Within this cosmic cul-de-sac, there are roughly 34 stars. Most of them are red dwarfs, violent volatile stars that bombard their planets with sterilizing solar flares. Worlds in their habitable zones are tidally locked, featuring one hemisphere boiling in perpetual daylight and the other frozen in eternal night. Even our most celebrated exoplanets, hailed in headlines as Earth-like, are deceptive. Venus and Mars sit roughly in our sun's habitable zone, yet one is a pressurized acid bath and the other a freezing, irradiated desert. Traveling decades to reach a theoretically habitable exoplanet, only to find a suffocating tomb, will be the most devastating anti-climax in the history of our species. The grim reality is that a second Earth, a true paradise with liquid oceans, a stabilizing moon, and a breathable atmosphere, is incredibly rare. The nearest viable candidate might be hundreds, perhaps thousands of light years away. At 20% the speed of light, this journey transcends a single human lifespan. It becomes a generational odyssey lasting millennia. Thousands of descendants will be born, live, and die inside a decaying metal tube, entirely disconnected from the concept of a blue sky or the feeling of wind. Entropy guarantees that life support systems will inevitably fail. Biological mutations from deep space radiation would slowly rewrite their DNA. They would forget Earth. They would forget why they were traveling. A generational ship isn't a colonizing vessel. It is a floating tomb hurtling toward a destination its passengers no longer understand.
The math seems insurmountable. The physics appear absolute. The cosmic quarantine is sealed. But humanity has a fascinating habit of being incredibly, spectacularly wrong about the limits of reality. To claim we will never leave the solar system requires us to assume our current understanding of physics is the final chapter of science. In October 1903, the New York Times published a scathing article declaring it would take engineers 1 to 10 million years to invent a functioning flying machine. It was a mathematical certainty. Exactly 69 days later, two bicycle mechanics named Wright achieved powered flight on a windy beach in Kitty Hawk. 66 years after that, human boots left imprints in the lunar dust. The greatest barrier to the future has always been the profound arrogance of the present.
We won't conquer the stars using combustion and metal of today. The solution won't be building a faster rocket. It will be evolving beyond the fragile ape. Perhaps we master biological immortality, transforming a 1,000-year voyage into a passing season. Perhaps we send hyper-intelligent synthetic minds, carrying our digital consciousness across the void in vessels the size of a thimble, immune to the shrapnel of space. Or perhaps we unlock new dimensions of physics entirely, manipulating space-time in ways that make velocity irrelevant. We are a young species, barely awake in a universe 13 billion years old. The stars remain impossibly far, but human curiosity is an unstoppable force of nature. And if the outer cosmos is truly barred from us forever, perhaps our ultimate destiny lies somewhere else entirely, deep within